on the limiting reagent worksheet. So we're given this chemical equation. First off, is this equation balanced? No, it's not balanced, which means we have to balance it before we can go on to anything else, right? Okay? So we need to write AL, we need to write O, and we need to write FE. Okay, I'm going to tell you a trick real quick. I can look right now and I see a 3 for one O and I see a 4 for the other. There's nothing times 3 that gives me 4. That's a whole number, right? So I'm going to do a 3-4 trick before I start. It's just going to save me a little bit of time. So I'm going to put a 3 in front of the side that has the 4. I'm going to put a 4 in front of that one. Okay, how many ALs do I have on the left right now? 8. How many oxygen on the left? How many iron? On the right, how many aluminum? 1. How many oxygens? How many irons? 9. What times 1 gives me 8 for aluminum? So I put an 8 in front of this aluminum, that changes that from a 1 to an 8. What times 1 gives me 9? 9. So I put a 9 in front of that iron, that gives me 9 irons, everything's balanced out. Have I lost anyone yet?
No.
Everyone have their notes out. Okay. Next thing up. It says I have 25.4 grams of aluminum oxide and I have 10.2 grams of iron. I need to determine the limiting reagent or reactant. Same thing. Okay. How do I start my problem? Okay. I'm going to start with what I have. So I'm going to do 25.4 grams of Al2O3. Okay. Now, my next question is, where am I trying to go to? What am I trying to convert this aluminum oxide to? Okay, I want to go to moles of Al. And the reason is, if I look at letter B, it says determine the number of moles of Al produced. So I don't want to go through a problem more than once if I don't have to, right? So that's where I'm going to go. I'm going to go to moles of Al. So I start with 25.4 grams of Al2O3. And over here at the end, I know I want to get 2 moles of just aluminum. Okay, so right now I've got grams on top. So I don't want my answer to be in grams of aluminum oxide, so I need to get rid of grams of aluminum oxide. I'm going to put it on the bottom. Okay, of my 3 conversion factors that we've talked about, what's the only one that has grams in it? Molar mass, right? That means I have to put moles on top. And we can calculate molar mass for Al2O3. That means I have 2 aluminum times the mass of aluminum from the periodic table. Okay, it's 26.982. Plus, I've got 3 oxygens. So that's 3 times 15.999. I multiply and add, and what do I get? (101.961). Anyone else get that? Okay. Grams per mole. So where does this 101.961 go? The top next to the mole or the bottom next to the gram? Bottom next to the gram, because 101.969 or 961 is touching the G. And what goes in the top blank? Just a 1. Okay? So now I'm in moles of aluminum oxide, but I don't want my answer in aluminum oxide, do I? No, so I got to get rid of it. So I'm going to put mole of Al2O3 on the bottom. Now, how do I fill in the numbers for this mole ratio at the end? I use the coefficients from my balanced chemical equation. So if I go back up to my balanced chemical equation, I see that in front of the aluminum, I have an 8. And in front of the aluminum oxide, I have a 4. Okay, so what I do now, I can go back and check through my units, moles of aluminum oxide, grams of aluminum oxide, grams of aluminum oxide. And I'm going to be left with moles of aluminum. And I need you to multiply straight across on the top. Okay, so what was it? 203.2. And on the bottom, 4 times 101.961. 407.844. Divide top by bottom. Point. What is it? Okay, 0.498 moles of aluminum. Okay. So I've checked the first reactant. Now I need to check my second reactant, which was 10.2 grams of iron. Okay, so I'm going to start the problem over, but I'm going to start this time with 10.2 grams of iron. And what am I trying to go to again in this one? I'm going to go to moles of Al again. And again, the reason I'd go to moles of Al, if I look at B, it tells me I need answer in moles of Al. And I have to go to the same product for both of them because I'm going to make a comparison between the two to figure out which one was my limiting reactant. Okay? So right now I've got 10.2 grams of Fe on the top. So to get rid of that, what do I have to do? That's right, I put grams of Fe on bottom. And then I ask myself, what's my only conversion factor that has grams in it? Molar mass. That means moles of Fe will go on top. And I've got to do the molar mass of Fe, which is going to be pretty simple. Molar mass of Fe is right off the periodic table as 55.845 grams per mole. So does that 55.845 go on top or on bottom? Bottom. On bottom. And what do I put on top? Just a 1. All right. So I've got moles of Fe on top now. I need to get rid of it. Put moles of Fe on bottom. Okay. And now I just need to fill in my numbers like I did before. What's the coefficient in front of the Fe? Was it a 4? It was a 9. And what's the coefficient in front of the aluminum? All right. Going to multiply straight across on top. Multiply straight across on bottom. 2.605. Top divided by bottom. 4. 0 point. Is that right? Moles of aluminum. All right. What I got to do now is compare. I'm looking at that number and that number. Which one is smaller? Okay, the 0.162 moles of aluminum is smaller. That means I used up all of my iron to get to 0.162 moles of aluminum. I could not use all 25.4 grams of aluminum oxide to get to 0.498 moles of aluminum. That means my limiting reagent, the one that I ran out of, is Fe. So the answer for A is going to be Fe, iron. The answer for B is how many moles of aluminum can you make, is 0.162 moles of aluminum. Hey, do I have any questions so far? Okay. Let's go on to C. C says determine the number of grams of iron oxide produced. So I'm going to go over here, and I'm going to start with what I had last time. 0.162 moles of aluminum. And way at the end, I need to get to grams of to be iron. How many irons? C3O4. Okay. So right now I've got moles of aluminum on top. What do I need to put on bottom? Moles of aluminum. And remember, you can switch from one compound to another when you're at moles, right? So I use my mole ratio to go from moles of aluminum into moles of Fe3O4. But I don't want my answer to end up in Fe3O4 moles, so I'm going to put it on the bottom. Okay. I've got to fill in my mole ratio. So what number was in front of Fe3O4? And what number was in front of Al? 8. And that last one's grams and moles. That's called molar mass again. So we got to calculate it. Molar mass. We have 3 Fe's times 55.845 plus we have 4 O's times 15.999, and that gets us what? Oh no, we've got conflicting answers. All right, 231.531 grams per mole. All right, and it attaches to the grams. We got 231.531. We're going to multiply straight across on the top again. 0.162 times 3 times 231.531. One 2 point. What we get? 112 point what? That's going to be far enough. Divide that by 8. So 14.066. We started with 3 significant figures. It's 14.1 grams of Fe3O4. All right. So we should have gotten, let me make sure, that was supposed to be 112. Okay. So we got our answer, 14.1 grams of iron and oxygen there. And we move on to number D, or letter D. Determine the number of grams of excess reagent left over in the reaction. So which one of our reactants was excess? The aluminum oxide, because we had too much left over, right? So we're going to be going to grams of aluminum oxide. Now, the other question is, where do I want to start? Because I've got a lot of things I've calculated. I can start with how many grams of iron oxide I had. I can start with grams of iron. I could start with lots of things. Which one do I want to start with, though? I like starting with moles because it makes it to where it's just a two-step problem. So I'm going to start with 0.162 moles of aluminum again. So I know how many moles of aluminum I have, right? I'm going to use that one. Get rid of moles of aluminum, put it on bottom. I'm going to switch to moles of my other substance. So I'm going to go to moles of, okay. And then on the bottom I need again moles of Al2O3. Okay, so what was the coefficient for Al2O3? 4. The coefficient for aluminum was 8. What was the molar mass of aluminum oxide? We've already calculated it. 101.961. All right, multiply straight across on the top. $66.707. 070. And we're going to divide by 8 on the bottom. 8.26 grams of Al2O3. Now, is this how much I have left? No. This is how much I have used. So I start with what I had. So how many grams did I have to start with? So we have we started with minus what we used. So what was it? 17.1 grams. And that's the problem.